While Tesla has been a pioneer in lithium battery innovation, a new player might just shift the balance: the PolyJuel plastic battery. With up to 12,000 charge cycles, that's 6 times more than Tesla's 4680 cell, and the ability to deliver a megawatt of power in just 10 seconds, this tech could be a game changer. Even more impressive, it's made from 99% recycled plastic, making it lighter and greener. Could this spell the future of batteries, one even Tesla has to take seriously? Before we dive in, help us reach our next milestone of 40,000 subscribers. Your support drives us to keep sharing everything from the Tesla Model Q to emerging EV trends and beyond. How plastic batteries work. Let's unpack how this innovative PolyJuel battery works and why it's making waves in energy storage. At the core of any battery is the ability to convert chemical energy into electrical energy. You've got 2 electrodes, a positive cathode and a negative anode, separated by an electrolyte. When connected in a circuit, electrons flow from the anode to the cathode, generating electricity. Battery efficiency comes down to 3 things. Power density, how fast it can deliver energy. Energy density, how much energy it holds per weight or volume. Capacity, total energy the battery can store. Most current batteries, like lithium-ion types, use metal electrodes. They're effective but not without downsides: high cost, environmental impact, risk of fire, and gradual performance loss over time. Enter PolyJuel. Instead of metals, it uses conductive plastics, polymers, to do the job. These are lighter, cheaper, safer, and non-toxic. Though made without metals, these batteries still pack serious performance. That makes them ideal not just for devices, but also large-scale energy storage. The science behind it. So how do you turn plastic, normally an electrical insulator, into a conductor? Plastics are built from long molecular chains called polymers. On their own, they don't carry electricity. But add in the right chemicals through a process called doping, and they gain free-moving electrons, or holes that let current flow. This creates 2 types. P-type, positive with holes. N-type, negative with electrons. These form the backbone of plastic-based semiconductors, solar cells, and now batteries. PolyJuel's setup uses 2 types of these conductive polymers for the anode and cathode, separated by a polymer-based electrolyte. Materials like P3HT for the cathode and polyethylene oxide for the anode are chosen for their specific properties. The electrolyte, often polyethylene glycol mixed with salts, allows ions to travel but keeps electrons in check. Charging moves electrons from anode to cathode and ions through the electrolyte. Discharging reverses the flow, powering your device. How it stacks up. Compared to traditional batteries, PolyJuel stands out in several ways. Energy density can hit 1000 Wh/kg, about 4 times lithium-ion. It's lighter, non-flammable, and more durable. Ideal for everything from smartphones to EVs and grid storage. And yes, one last reminder, we're subscribers this month, so if you're enjoying this content, hit that button. Cost and lifespan. Here's where it gets even more interesting. Though energy density for PolyJuel currently averages around 60 Wh/kg, lower than Tesla's 4680 battery, its weight is dramatically reduced. A typical 4680 cell weighs around 355 grams. A PolyJuel cell? Just 71 grams. That weight reduction means better efficiency in large systems. Even better. Price per kilowatt hour, $1.65 today, compared to $132 for lithium-ion. Expected future price, less than $20 per kilowatt hour. Lifespan, up to 30,000 cycles, nearly 100 years of use. For context, powering your house for an hour might only cost $325 in PolyJuel batteries today. For a full-day system, about $6,500. Chemical design and real-world use. So what's inside? Instead of rare metals, PolyJuel relies on organic compounds, carbon-based polymers with alternating bonds that allow for smooth electron travel. This makes the batteries not only efficient but safe and recyclable. The electrolyte includes a graphene-carbon blend, which is stable and fire-resistant. The whole process, from charge to discharge, works on standard redox reactions but uses advanced materials and industrial design to scale. The first major field test? A dairy farm in New Zealand operated by the Fonta Group. They installed an industrial PolyJuel battery system, which has now run for 10 months straight, powering milk processing operations. Soon, they plan to test it in trucks and in areas hit by frequent power cuts. Impact and applications. With fast charge/discharge, safe materials, and long life, these batteries could transform home energy systems, grid storage, electric vehicles, portable devices. Even more, it could significantly lower energy costs in places like New Zealand, where integration with the national grid is already being explored. Why Elon might be watching. Elon Musk and Tesla have long prioritized eco-friendly energy solutions. But lithium mining has faced ethical and environmental concerns, such as the controversy around mines in Argentina. If plastic-based batteries can truly deliver, Musk may see strategic value in adopting the technology, especially for Tesla's Powerwall or Megapack storage systems. Today's grid-scale lithium batteries deliver for hours of power. PolyJuel, on the other hand, retains 92% of charge over 20 hours in tests. And the kicker? These batteries are fully recyclable and burnable as standard waste, no toxic byproducts or specialized disposal required. Musk has already said Tesla's 4680 cells are recyclable, but with PolyJuel, recycling may be even easier and cheaper. Final thoughts. So what's your take? Could plastic batteries power the next energy revolution? Will Tesla get on board? Drop your thoughts in the comments. We'd love to hear from you. And if this deep dive helped you learn something new, consider subscribing and turning on notifications. It really helps the channel grow and keeps us motivated to bring you more stories like this. Thanks for watching Next EV Insights. Until next time, stay curious and stay charged.